Hello everyone, this is Ganesha and studying in Sri Venkateswara College of Engineering, and today I'll be teaching you guys the topic about swarm intelligence. Let's come to the introduction of swarm intelligence. It was introduced by Gerardo Benny and Jin Wang in the year 1989. SI simply means using the knowledge of collective objectives together and then reaching the optimized solution for a given problem. Swarm means a group of objects, peoples, insects, etc. In other words, let's say we give a problem statement to a single person and tell him or her to go through this problem and then give the solution. Then this means that we will consider the solution of that particular person only. But the problem is that the solution gives by that person may not be the best solution, or maybe that solution is not good for others. So, to avoid that, what we do is that we give that problem to a certain amount of people together, a swarm, and ask them to reach the best solution possible for that problem. And then computing all the responses together to reach the best solution possible. So here we are using the knowledge of the group as a whole to reach to the best solution or optimized solution for that problem, and that solution will be good for all of them individually too. So that is the idea behind swarm intelligence. Now let's take an example to prove that collective knowledge of objects is better than any individual object. For example, let's say we have a jar of 500 marbles containing. The question is that without touching the jar, a person needs to predict how many marbles are in the jar. Suppose we take only one response from a person and according to him, the jar contains something like 400 marbles. So, by this result, we conclude that this estimation of that person is not very bad since the difference is only 100. But this might not be the best solution. We can optimize this even more. So, now that what we'll do is that instead of taking response from only one person, we will be taking responsible from 10 people, let's say. Let P denote the number of people from P1 to P10. The average. We'll calculate the average from all those people and then come to the decision saying it's only 488 marbles in the jar. Now, from this, we can say that from the collective predictions from 10 different persons, we have reached a more potential answer that is 484 marble in the jar. We are very close to the actual result of 500 marble in the jar. Here, in this case, the difference reduces to only 16 marbles as compared to the previous error, which was 100. So, that is the main idea behind the swarm intelligence, that is, to use the collective knowledge of objects. Why swarm intelligent? The answer to this is simple now, and we proved this in our previous marble example, which is collective, collecting the answer and responsible responses from different objects individually, and then computing all responses as a whole to a solution that best fits our given problem. So, here with this approach, we are having a more optimized solution for a given problem, and that is the reason why swarm intelligence came into the picture. Because of this reason, we can use it in different scenarios of life, for example, forecasting which policy is good for the business, etc. So simply we are using the brains to reach the solutions of a given problem. If we will observe in our surroundings, then we will be able to find many examples of swarm intelligence like ant colony, swarm of bees, flock of birds, etc. And in reality, also the idea of swarm intelligence was taken from nature only. And now we will be going through ant colony, swarm of bees, how it works. Ant colony. If we observe closely, then the ants also follow the principle of swarm intelligence. For example, to build a home, they collect mud particles from the surrounding and individually have a responsibility to build their home. They communicate through signals and pheromones. Ants use this for tracing other ants, and regardless of what other ants are doing, an individual ant is responsible for only its own contribution to build the home. Similarly, when they reach for food, then at first they search individually for food, leaving the pheromones behind. And once they find the food source, then that ant communicates with other ants, and then other ants can trace it and follow the path to reach the source of food instead of just randomly searching for food in different locations every time. So when it comes to swarm of bees, bees also use the same principle for their survival. That is, when they search for a place like where they can build their hive, then the task of each bee is to consider several parameters that the hive will which will be built should be on a good height to avoid predators, should be near water source, should be near pollens, etc. Then they use their collective research and finally find a place and decide on it, and then where the hive would be considered built. All of those parameters, and then they reach the best solution for that problem. Now, what is artificial swarm intelligence? It is also known as a human farm. Here also the idea is same that we randomly make some of the persons participating in a real-time system and tell them to find the solution for that particular problem. Individually, the final solution is then computed after taking responses from each participant, and the final solution is presented, which is more optimized as compared to the solution taken from only one participant. The objectives are optimization. One of the primary objectives of swarm intelligence is to optimize solution to complex problem. This includes tasks such as optimization of functions, routing, scheduling, and resource allocation. The next one is adaptation. SI aims to create systems that can adapt to changes in their environment or objectives without explicit programming. This adaptability is essential for applications in dynamic and uncertain environments. Self organization. SI seeks to understand and harness the self organizing principle observed in natural forms by allowing agents to interact locally and autonomously. SI system can achieve global coordination and organization without centralized control. Robustness. Another objective of SI is to create robust system that can maintain functionality even in the face of individual failures or environmental disturbances. Robustness is essential for application requiring resilience and fault tolerance. The next one and the last one is scalability. SI aims to develop algorithms and systems that can scale to large number of agents or components without sacrificing performance or efficiency. Scalability enables SI to address problems of increasing size and complexity. The advantages of swarm intelligence are robustness, where SI systems often exhibit robustness against individual failures. Even if some agents in the swarm malfunction or are removed, the SI system as a whole can continue to function effectively. Adaptability. SI systems can adapt to changes in their environment or objectives without central coordination. This adaptability makes them suitable for dynamic and uncertain environments. When it comes to scalability, SI algorithms can scale to large numbers of agents or components without significantly increasing complexity. This scalability is particularly useful for tasks that require massive parallelism. The next advantage is distributed processing. SI distributes decision making and problem solving processes across multiple agents, which can lead to faster and more efficient solution, especially for complex problems. The exploration of solution space. SI algorithms often explore a wide range of solutions in parallel, increasing the likelihood of finding optimal or near optimal solution to complex problems. Now, let's come to disadvantages. Lack of control. The decentralized nature of SI system means that they can be difficult to control or predict. Unforeseen emergent behaviors may arise, leading to unintended consequences. Vulnerability to noise. SI algorithms can be sensitive to noisy environment or unreliable communication between the agents, which may degrade performance or lead to suboptimal solutions. Limited problem domain. While SI is effective for certain types of problems, it may not be suitable for all the tasks or problems domains. Some problems may require centralized control or specialized algorithms for optimal performance. When it comes to complexity, the last of the disadvantages, understanding and designing SI systems can be very complex. Especially as the number of agents or components increases, analyzing emergent behavior and optimizing system parameters may require significant computational resources. And this is the end of my presentation based on swarm intelligence. Thank you, everyone. Have a nice day.